today's video lecture, we will just start with a recap of what instantaneous velocity is and then move on forward to how we can define a derivative. As we had seen earlier, instantaneous velocity we defined in the pattern formed by three steps in which if y is equal to f of x is our function and we had a particular time at x naught which is fixed, then we formed the average velocity over the time interval from x naught to x naught plus delta x to be equal to delta y divided by delta x, which is equal to f of x naught plus delta x minus f of x naught the whole divided by delta x. So we had earlier seen that if the initial time is x naught, the final time is x naught plus delta x, then the time interval will be x naught plus delta x minus x naught, which is equal to delta x. If simultaneously, when the initial time is x naught, the initial distance will be correspondingly f of x naught. If the final time is x naught plus delta x, the final distance will be f of x naught plus delta x. Then the distance travelled will be the difference of f of x naught plus delta x and f of x naught. And we denoted it as delta y. So the average velocity we defined it to be delta y divided by delta x, right? And in the second step, we simplified the expression we obtained for this delta y by delta x as much as possible by cancelling out delta x from the numerator and denominator as much as we can. And in the third step, what we did is we try to find a number, small letter v, which is approximated by delta y by delta x whenever this delta x is moving close to the value 0. So we illustrated the definition with example 3. We solved it. In that example, to recap, we had the position or the distance function to be y is equal to f of x, which is equal to 3x squared plus 8x. And we had to find the instantaneous velocity at an arbitrary positive time x naught, which we found out using this pattern of steps, that is delta y by delta x. We found out the average velocity and then we made this delta x to go to approach to 0 and we obtained delta y by delta x to be approaching or moving close to 6x naught plus 8 whenever this delta x is approaching 0, right? So what we obtained is the instantaneous velocity, we obtained the value to be 6x naught plus 8, which is seen here. That is small letter v, the instantaneous velocity is equal to 6x naught plus 8 meters per second at the arbitrary time x naught. And then we found out the instantaneous velocity at what time the instantaneous velocity will reach 11 meter per second. So we just equated what we got. We know that the instantaneous velocity v is equal to 6x naught plus 8. We substituted instead of v as 11 and then we obtained x naught to be equal to 1 by 2 second. That's how we ended up the last video lecture. And now let's see how we can pace forward in this section. So our next aim is to find the slope of the line tangent to the graph of a given function. It's very easy. We had seen such areas while we were studying in our high secondary. So just think about all these sections as a recap to what we had done there. Okay. So how will we find the slope? Okay. To solve this problem, so suppose we have a function y is equal to f of x. See, you can see a function sitting here. Okay. We we are drawing a function y is equal to f of x. So this curve, suppose this curve sitting here, this darkened curve is y is equal to f of x. Okay. And suppose this is x naught, the point x naught, where you are seeing the cursor right now, x naught. So correspondingly this will be f of x naught. So this point here will be represented as the ordered pair x naught comma f of x naught, right? And suppose if this is x naught plus delta x, then correspondingly this will be f of x naught plus delta x, and the point here can be represented as the ordered pair in the braces x naught plus delta x comma f of x naught plus delta x, braces closed, right? So we saw what the points are: x naught, f of x naught, the ordered pair, and the ordered pair x naught plus delta x comma f of x naught plus delta x. Now we are going to draw a straight line joining those 2 points. To draw a straight line, we actually need how many points? Just 2 points. So we are joining them. Now, for our inference, we know that the distance here, where you are seeing the cursor moving, that distance will be delta x, right? Because that distance will be del x naught plus delta x minus x naught, which is delta x. Similarly, this distance, the distance here will be delta y. We denote f of x naught plus delta x minus f of x naught to be delta y. Okay. So we said we draw an extra line, a straight line joining these 2 points. See, you can see the arrow here showing the line. Okay, this is a straight line. Already we have the function which is a curve, and we draw a straight line here. This straight line is called a secant line joining 2 points of the function. The straight line joining 2 points of the function is called a secant line. And how do we find the slope of a line, straight line? We draw the corresponding parallel line from this point to the x-axis. So this is the parallel line, right? This one. And we draw the corresponding parallel line to the y-axis, this line. Okay. And this is the angle which the line makes with the x-axis. The line parallel to the x-axis, we call it theta, and tan theta is the slope of this line, right? So tan theta means this, you have this triangle to be a right angled triangle, this one. So you can say that tan theta will be equal to the opposite side divided by the adjacent side. That means delta y by delta x, right? So the slope of the secant line is nothing but secant line is nothing but tan theta, which is equal to delta y by delta x. So here delta y by delta x is equal to, we know what delta y is, which is equal to f, in the numerator, f of x naught plus delta x minus f of x naught divided by delta x. So that is the slope of the secant line which we defined now. So remember what a secant line is, how we defined it. Okay. Now what you're going to do is, we are going to make the distance between this x naught and x naught plus delta x very close. Okay. So look at this diagram. So here you know that this is x naught, this is delta x naught plus delta x. So you're going to make it, this x naught plus delta x, go closer and closer to x naught. Okay, so when we do that, and when we try to draw secant lines, so at first, suppose the x naught plus delta x, x naught plus delta x was here. In the second time, we know that this is, we are making it closer. If suppose if this is delta x naught plus delta x, and we are moving it closer and closer. Okay, so when we are making it move closer and closer, what happens is, when we draw the secant line, that is the line which joins x naught comma f of x naught and x naught plus delta x comma f of x naught plus delta x. If we are joining the points sitting here, we are getting the secant lines, right? So when we are making this x naught plus delta x to get closer to x naught, these secant lines are approaching the tangent line. See, all the secant lines. The first secant line was this. The first secant line was this. The second secant line was this. The third secant line was this, and this is the tangent line. You know what is a tangent line? That is, if we have a function like this and a point like this is called the tangent line. The tangent line touches the curve only at that point. Okay, so this line is called the tangent line of this function at this point x naught. Okay, so whenever this x naught plus delta x is moving closer to x naught, we are analyzing that the secant lines are approaching the tangent line, moving close to the tangent line. And that's when we are going to define what the slope of a tangent line is. And when you are seeing how we are going to define the slope with a pattern, you can just relate it to the definitions of average velocity and instantaneous velocity. Okay, so here we have a function y is equal to f of x. The slope m of the line tangent to its graph at the point x naught y naught ordered pair x naught y naught is calculated using the following steps. Okay. First, you have to form the slope of the secant line. We know that the secant line has the slope delta y by delta x, right? We just said about that earlier. And then what you have to do in the pattern? Simplify that expression of delta y by delta x by cancelling out all delta x from the numerator and denominator as possible. Okay, as we did earlier. Then what we do is make this delta x go closer to the value 0 and then find the number m which is approximated by this delta y by delta x. The similar pattern which we followed to find instantaneous velocity and average velocity earlier. So to illustrate this, let's see an example. So in this example, you have to calculate the slope of the tangent line to the graph. You are given a graph of the function f of x is equal to x square plus 1 and you are given the point at x naught is equal to minus 1. Indicate your result on a sketch. We are asked to draw the sketch also. So how do we find the tangent, slope of the tangent? First you have to follow the step 1. Step 1 which means delta y by delta x, right? Which is the average, which is the slope of the secant line. Okay. We had rephrased average velocity to slope of the secant line now. So you just keep in mind how we rephrase the all the mathematical terms. Okay, so the delta y by delta x is equal to f of x naught plus delta x minus f of x naught divided by delta x. And follow the substitutions. That means instead of x, at first you have to put x naught plus delta x. So here we will be having minus x naught, you have to be minus 1. So in order to make it more clear, this is equal to f of x naught, you have 1 minus 1, right? So go for minus 1 plus delta x minus f of minus 1 divided by delta x. Then substitute. Instead of x, substitute minus 1 plus delta x the whole square plus 1, that is the first term, minus you have f of minus 1. Instead of x, you put minus 1. That is minus 1 the whole square plus 1 the whole divided by delta x, which is equal to, when you just cancel them out and simplify it properly, you will get minus 2 into delta x plus delta x the whole square divided by delta x. Then we can cancel out delta x uh, because delta x is not equal to 0. Delta x is never 0. So we can cancel them out. How do we cancel? Yeah, we cancel them out like this, taking this delta x out. So you get minus 2 plus there were delta x a whole square. That means delta x into delta x divided by delta x. So you can cancel them out and you get minus 2 plus delta x. So whenever, so what you did is now you simplified the expression delta y by delta x as much as possible. We cancelled out delta x from the numerator, denominator and so on. Right. Now we are going to the third step. So this delta x is made to approach to 0. When delta x is made to approach to 0, we know that this delta y by, the value of delta y by delta x will be moving to minus 2. So here the value for m, we are giving it the notation m. M will be minus 2. Okay. So to give it in a sketch, so this will be the sketch. Here y is equal to x square plus 1 is drawn, the parabola. To understand it, you know that y is equal to x square, the parabola will be uh, sitting like this. Y is equal to x square. If y is equal to x square minus 1, the parabola will shift downwards to minus 1. The vertex of the parabola will be minus 1. If y is equal to x square plus 1, the parabola will shift upwards. The vertex will be 1. So here we have the function to be y is equal to x square plus 1. So it is shifting to the upward part with in 1 units. So this is 1. This value is 1. Okay. Um, okay. Now what you have to do is, see the slope we now obtained is actually minus 2. See, m is equal to minus 2 is what we obtained. Suppose in the question we are given a particular point, right? See, x naught is equal to minus 1. The point x naught is equal to minus 1. When x naught is equal to minus 1, f of x naught is equal to f of minus 1, which is equal to substitute minus 1 instead of x. So that is equal to minus 1 the whole square plus 1 is equal to 2. So the point in which the question of the question where we have to find the slope is x naught ordered pair x naught comma f of x naught, that is minus 1 comma 2 ordered pair, right? So this is the point. If we float, we get this to be minus 1 2. So we have to find the slope at this point. So you have to draw the tangent at that point. So this is a tangent. So what will be the slope there? The slope will be minus 2. That is which we had calculated in the earlier part of the solution. So that's how we sketch the question. Okay. So you can understand that here we said the slope m is equal to minus 2. So it doesn't depend on x, right? So that means for any point on the parabola, corresponding slope of the tangent line will be minus 2 here because it doesn't depend on x. Okay. So that's how we define the slope of the graph of a function at the point x naught, at the point ordered pair x naught f of x naught. It is the slope of the tangent. tangent line, corresponding tangent line at that point. So when we were talking about delta x till here, we were thinking that delta x is positive. It need not be always positive, but what we have to keep in mind always is that delta x is never taken to be 0. That is delta x can be any value other than 0. It can be positive, negative or whatever value. So we saw the patterns while we were defining average velocity, instantaneous velocity, slope and so on. And delta y by delta x is a quantity which comes in each of the steps, right? So we understand that this is an important notation and we are giving it a term called difference quotient. Difference quotient. So from now on we are going to call delta y by delta x and it is renamed as difference quotient. And we get a number in the final step when we make delta x approach to 0, right? Some value which we used to call instantaneous velocity or slope. From now on, we are going to call it derivative. And the notation we use is f dash at x naught, which means that this is the derivative of the function at the value x naught. Okay. So we can define the derivative in the same manner as we defined the instantaneous velocity, slope, etc. So to calculate the derivative f dash of x naught of a function, y is equal to f of x at x naught, form the difference quotient. The difference quotient is nothing but delta y by delta x, which is equal to the numerator f of x naught plus delta x minus f of x naught divided by delta x. And the second step, we have to simplify this term, cancelling out all the delta x wherever possible in the numerator and denominator. Okay. And in the third step, we make delta y by delta x to approximate to a value when this delta x is made closer to 0. And this operation of finding a derivative is called as differentiation. Okay. Now let's move into example 5. Suppose m is a constant. We have to differentiate f of x is equal to mx plus 2 at the point x naught is equal to 10. So differentiate means we have to find, differentiation means it is a process of finding the derivative. That means we have to find f dash of x, f dash of x at the value 10. Okay. So what do we have to do at first? The same pattern as how we defined here for the derivative. So that means first you have to calculate delta y by delta x. Okay. Delta y by delta x is equal to f of x naught plus delta x minus f of x naught minus f of x naught here divided by x naught plus delta x minus x naught. That means delta x in the denominator. And then you substitute x naught to be 10, it is given in the question, and then substitute for the function here. So that means m into, right, 10 plus delta x plus 2 minus m into 10 plus 2 whole divided by delta x. That is equal to, when you simplify, you get m into delta x divided by delta x. You can cancel out delta x to get the value m. That means delta y by delta x is equal to m. It doesn't have any value, doesn't have any term related to x here. Okay. So that means this approximates when delta x is approaching to 0, this value is approaching to m. Already it only has the value m. So we have here f dash of x is equal to m for all values of x, okay, in the domain. Now what you are going to do is just observe this function was f of x is equal to ax plus b, and then we call this function as a linear function because see the in the example we had f of x to be equal to mx plus 2. You can see that m and 2 are constants and x is having the degree 1. So the function, such functions are called linear function. That means here f of x is equal to ax plus b. So here f is linear. Okay. Now we we found that the corresponding derivative is m. If f of x is equal to ax plus b, the corresponding derivative will be a. And in the next section, what we are going to do is, if we have a function which has which is having the value degree of x to be 2. That means if the function is of the form ax square plus bx plus c, it is usually called the quadratic function, where a, b and c are constants. Okay. And let x be a real number. Then f dash of x naught is equal to 2a x naught plus b. This is what we have to find out from what we were saying earlier in the theory. So we have to prove this. That means if we have the quadratic function to be this, we have to say that the derivative is the guy sitting here. Okay. So delta y by delta x is calculated as f of x naught plus delta x minus f of x naught divided by delta x, which is equal to a into x naught plus delta x the whole square plus b into x naught plus delta x plus c minus ax naught square minus bx naught minus c the whole divided by delta x. Okay, then open the braces. Here we have x naught plus delta x the whole square. That will be nothing but x naught square plus 2 into x naught into delta x plus delta x the whole square, and then open the braces to multiply it with a. You get here and open the braces and then simplify, cancelling out all the plus minus terms. Then you get the value sitting here. Then you can cancel out the delta x from the numerator and denominator to obtain the value sitting here. Now when delta x is approaching 0, what happens is delta y by delta x will move to 2ax naught plus b, right? So what we obtained is, we got that f dash of x naught is equal to 2ax naught plus b. So this is called as the quadratic function rule. That is, whenever the function is of the form of a quadratic function, you get the derivative to be the term sitting here. Okay, now let's see example 6. In this example, we have to find the derivative of the function f of x is equal to 3x square plus 8x. You can see the degree of this x is 2. That means this is a quadratic function here. We have to find the derivative at x naught is equal to minus 2, also at x naught is equal to 1 by 2. So there are two heads. Okay, in the first head, we know that instead of a you have 3, b you have 8 and c you have 0 in the definition earlier in the quadratic function rule. So just substitute for f dash of x naught. X naught is minus 2 here, so that will be, on substitution you'll be getting it as minus 4. Similarly, you try for x naught is equal to 1 by 2. So you get f dash of 1 by 2 on substitution to be 11. So let's summarize what we got from here. That is how to differentiate the simplest functions which you know. The first function which we come along is f of x is equal to ax square plus bx plus c. We just said about it earlier, and this is called the quadratic function. The corresponding derivative is f dash of x is equal to 2ax plus b. Earlier we said in the quadratic function rule we gave here it to be x naught. So here also it was x naught. Here we generally give it as f dash of x, that is equal to 2ax plus b. And you know that the degree of the derivative here, the degree of x is 1 here. That means this is linear. So if the function is quadratic, then the corresponding derivative will be linear. Okay. The next one is if the function is linear, f of x is equal to bx plus c, then it will be, the derivative will be the constant function b. You can just see in this question. See, in this question we did f of x is equal to mx plus 2, right? So when we found out the derivative, what you obtain? We obtain f dash of x is equal to m. That means the constant of the function x, constant of the term x, m. So if bx plus c is the linear function, then the derivative will be the constant b. And also if the constant if we are considering the constant function f of x is equal to c, then the derivative will be 0. Okay, so that is an important inference which we can collect till now. Okay, now let's see some examples. Example 7. Okay, so example 7 say starts with a statement which says there is one point on the graph of the parabola y is equal to f of x, which is equal to x square minus 4x plus 5, and at that point the slope is 0. Okay, that means the slope is 0 means suppose you have a function here. Okay, whenever you are having a function like this, okay, so this, if this is the point, we draw the tangent like this, right? That means this tangent is slanting. Slope is calculated for slanting lines. So here the statement is there is one point on the graph of the parabola where the slope is 0. That means the tangent line at that point is not slanting. That means it is of the form of a horizontal line. So you can see that this is the graph y is equal to x square minus 4x plus 5. Okay, and the slope is 0 means this is the point. This is the point where you are having a horizontal line to be the slope at that point. Okay, so you have to find the point where the slope is 0. Okay, so by the quadratic rule, function rule, we know that f dash of x is equal to 2x minus 4. Okay, you can calculate it like that. And we said that the slope is 0. That means f dash of x is equal to 0. That means 2x minus 4 is equal to 0. That means x is equal to 2. So when x is equal to 2, how can you find y? You got x is equal to 2 means f of x is equal to 2 square minus 8 plus 5, which is equal to 1. So the point we obtain is the ordered pair 2, 1. And this point is nothing but the vertex of the parabola. Okay. This is how we found out the point where the slope of the curve at that point is 0. Also, we can find it in a normal algebraic way. How is it we can find it? So f of x is equal to x square minus 4x plus 4 plus 1 can be rearranged and rewritten as x minus 2 the whole square plus 1. Okay, uh, and we know that x square minus 2 the whole square is 0 when x is equal to 2, right? So the parabola will have the lowest point at x is equal to 2. So this is 0 whenever 2 x is equal to 2. That means the lowest point is at x is equal to 2. Then from the figure when we draw the figure, you can understand that the point will be 2, 1, the lowest point on the parabola. And example 8 says about a stunt woman moving on a passenger train. Okay, so when we are talking about stunt women, I just thought I'll just introduce you to the first stunt women of Indian Bollywood industry, who is Reshma Patan. She is quite famous for the film in which she gave her stunts for Hema Malini in Sholay. So, so imagine such a stunt woman is moving on a passenger train. Okay, her distance function is f of t is equal to 3t square plus t, and on the adjacent track there is a long moving freight train. Freight train is nothing but the goods train. Okay, the distance function for the goods train is g of t is equal to t square plus 7t. Okay, what she have to do is she have to jump from this passenger train to the freight train at a best time. That means it should be she should be safe. So to solve this question, the safest time to jump for the stunt women will be the time at which both the trains are having the same velocity. Okay, so her instantaneous velocity at uh, of the person in the passenger train, as well as the instantaneous velocity of the freight train, has to be calculated. Freight train means goods train. So f of t is equal to 3. Suppose f of t is equal to 3t square plus t, then the instantaneous velocity v1 is equal to f dash of t is equal to 2 into 3t plus 1, which is equal to 6t plus 1. Similarly, the function of the goods train, we denoted it as g of t. G of t is equal to t square plus 7t. That means instantaneous velocity v2 is equal to g dash of t, which is equal to 2t plus 7. Okay, we have to make this v1 and v2 to be equal. That means 6t plus 1 is equal to 2t plus 7. Therefore, from that you can calculate t to be equal to 3 by 2 by rearranging the terms here. This 2t comes here, that means you have 4t is equal to 6. Then t is equal to 6 by 4, that is equal to 3 by 2. So that time 3 by 2 units is the safest time when this stunt women can jump from the passenger train to the goods train. So that is how we reviewed this chapter. And next is the exercise section, and I am just giving you a glimpse of which all exercises you should work on. I will just mention the numbers: 21, 22, 23, 24, 29, 30, 31, 32, 33, 34, 35, 36. Then you have to do 39, 40, 49, 50, 51, 52, 53, 54, and 61, 62. And you can try out more questions which are given in the exercise section. And in the next video lecture, we will be moving on to section 1.2, which is the section on limits. So thank you for being out through this lecture, and I would like to just add on a point that uh, keep a thorough lecture notebook with you, following all the lecture videos and solving out the exercises. And until we see in the next video lecture, goodbye. Thank you.